Hello, it's Yang. Today I'm going to explain how to do a stress analysis of a metal panel in Abaqus. There are 7 main steps that we have to follow in order to carry out the analysis. Firstly, we create the geometry. Then we define the material and we assign the properties to the geometry. Then we use the assembly function. This feature only exists in Abaqus. Then we create the load step. Then we create the mesh. And then we apply the boundary conditions. And we run the simulation. Finally, we can view the results. So in comparison with the other finite element softwares, the method to create the geometry is a little bit different in Abaqus. We create a sketch, then we create the panel. This is quite similar to how solids are created in CAE. We add dimensions to the geometry. We press enter. Now we define the material. We will use aluminum. We only have to define the Young's module and the Poisson's ratio. Here we are using megapascals and millimeters. As you may already know, it's you who define the unit system in finite element softwares. After defining the property, we assign the property to the geometry. Firstly, we create a section. And we define the thickness of the panel. Now we can assign the property to the geometry. Now we assemble the part. Now we create the load step. As we are doing a static analysis. Now it's time to create the mesh. This is a simple geometry, so the mesh size does not need to be very small. After the mesh is created, it's time to apply the loads and the boundary conditions. Firstly, we apply the shell edge load. Its units is Newton divided by millimeter. Now we define the fixed end boundary condition on one side of the panel. We define the same boundary condition on other sides of the panel. Finally, we define the boundary condition on the side where the load is applied. Here we should not restrain the displacement in the x direction, which is the direction of the application of the load. After all this, we can now create the job and run the simulation. After a few seconds, the simulation is completed, and now we can view the results. As you can see, the von Mises stresses is highest in the corners, as the displacement in the direction of the application of the load is restrained there. So this is the end of the video. Thank you for watching. Please like the video and subscribe for more contents. See you in the next video.